Hello friends, welcome to Inspire Chemistry. So today we'll be doing a very important reaction, also the name reaction BeckMann Rearrangement, which is regularly asked in all the examinations. So here we have an oxime which when have a acidic medium give you a secondary amide. So let's look into this reaction. So the reaction starts with a carbonyl group. When you add NH2OH in acidic medium, you have form an oxime. The reaction starts when you give this H plus, which comes from this pH. This OH tends to get protonated to form OH2 plus, which is a good leaving group. So in examination, you may find PCl3, PCl5R, COCl, Apple's reagent, or Lewis acids, which can be used instead of this H plus or H2SO4, which makes this OH a good leaving group, so that it can leave from here. The important thing you should remember is that when OH2 goes out, always the trans, whatever the trans alkyl group is there, migrates to this position, which will then give you a, let's say this is our compound. Sorry. This compound. Now, as you can see, we also have water in the system, which can then attack to this carbocation. Now this hydrogen can be removed. Which can easily tautomerize to give you an amide. This hydrogen goes to nitrogen and this double bond goes to here. So what you get is essentially this amide, which is a secondary amide. So this was the reaction for BeckMann rearrangement. So the question may not be coming so easy. So what you need to employ in examination, as you have less time, what you can do is that if you have an oxime, they give you some acidic medium. What you need to do is just migrate the trans, whatever, remember always the trans group that is trans to this OH migrates to this position. So all you have to do is migrate this alkyl group to this position and OH to here, which will give you this product. Now all you have to do is tautomerize this compound to form this amide, and here you have your product. So in examination they may ask you a difficult question. There are special cases where you have this alkyl group which is trans to this oxime. When the carbon here is allyl, phenyl, or tertiary carbon, which can form a stable carbocation, they tend to give more than one product. Let's see how. So here we have given you some questions based on those special examples. So first, I told you that if this carbon can have a phenyl, allyl, or tertiary carbon, this can form a stable carbocation. So here the question is number of all possible products in this reaction. This is the BeckMann rearrangement. So let's start with this reaction. As you can see, H plus will protonate this oxygen, forming a good leaving group. Now what happens is that here there's a possibility of formation of carbocation, which is stabilized by phenyl. So this bond is transferred to here and OH2 leaves. So what you'll get is a carbocation. Now there are two possibilities. Here you'll form a cyanide. So as the carbocation formed, there are two possibilities. As you have water also in the system and cyanide is also there, so this nitrogen can attack to this carbocation, as well as this water can also attack to this carbocation. One important thing is that we have been asked the all number of possible products. So if it had been, instead of H, it had been an R group, this would then may give you by SN1 reaction a chiral molecule, which will give you a racemic product. So also see such things in the reaction. So it's easy for us because there are only two hydrogens. So if this water attacks to this carbocation, you'll essentially have an abnormal product. But when this nitrogen attacks to carbocation, you'll have something like this. Now this water can attack to this carbocation and this bond goes here. And after this, this hydrogen can be removed as oxygen is has a positive charge to give you this species. And now you can easily tautomerize to form a amide. So how many products do we have? One is abnormal product, one is the regular product. Also in GATE examination, they once asked, they started the reaction from this stage. So you can have when you have NH2OH, you can also have product like this, where now here R1 was trans to OH, but here R2 is trans to OH. So you have to start the reactions from here and then proceed. Okay. Coming back to another good example which was asked in GATE is this molecule. As you can see, we have an oxime, and now this cyclic moiety is trans to this OH2. So as this OH2 receives a hydrogen here, forming a leaving group, you'll expect a trans migration from this position. But as you can see that there is a possibility of carbocation formation here, because carbocation so formed here will be stabilized by hydrogen by hyperconjugation. So it is very stabilized. So you'll have a question when you have a phenyl allyl or tertiary carbon or a stable carbocation. So what you'll get is this carbocation. Now if you form this conformation here, now similarly like the above mechanism, this nitrogen can attack to this carbocation, forming this product. The important thing to notice here is that the attack will be favored from the lower position rather than above position, because this hydrogen is given to be upsided. So the attack happens from lower end. And what you'll end up is this compound where the hydrogen and the amide are anti to each other. So this is a very important question. Please make note of this. Now comes the question which was recently asked in JAM 2019, where they gave this molecule and they asked us the BeckMann rearrangement. So what you have to do is that you have to protonate this OH to form a good leaving group. Now as you can see, this trans group should migrate to nitrogen and OH2 leaves. So what you'll have is this compound, and the carbocation will be formed here where this bond breaks, so carbocation forms here. Now you can number this ring 1 2 3 4 5 6 7. So you can equivalently draw this structure as this compound. Now this carbocation can be attacked by water in the solution, which will give you this product. Now, as the oxygen has positive charge, it can take back electrons from hydrogen. And once you tautomerize this, you'll end up with this answer, which was, I guess, option D. So that's all for today. Remember that BeckMann rearrangement is a important questions, and usually importantly JAM asks these questions very regularly. So thank you for watching this video, and if you like this video, please hit a subscribe button and we'll bring you such important videos ahead. Thank you.